Section 5.3 is on page 331, talks about exponential and logarithmic integrals. So if we want to integrate an exponential function, since the derivative of an exponential function is e to the x, to undo that, the integral of e to the x dx would be e to the x plus c. That's simple. I want to show you a trick. Instead of using a u sub, if I take a derivative of e to the kx, assume k is a constant, wouldn't that be e to the kx times k? Assuming k is a constant. So, if I want to integrate e to the kx dx, that'll save you some u sub every time, because this is almost always how you see it. That'll be e to the kx, and if you take a derivative, you multiply by k. If you take an antiderivative, to undo multiplication, you would divide by k. That's a trick that saves you 3 steps per problem, or 2 steps, which is the equivalent of the problem itself, because a problem normally takes about that many steps. So if I look at page 336, it says find the indefinite interval. Again, indefinite means there are no numbers there. And if there are numbers there, that's a definite interval. That's coming up in the next section. For now, I'm trying to figure out what did you take a derivative of to get this, and we know we could split this up. You don't have to show that. I'm just showing you the first problem, and I'm going to do this 2 different ways. So this is one way of doing it. I'm showing you what we're doing, and a constant I could drag out, whether I'm taking a derivative or an antiderivative. And this will be 6 derivative of e to the x. Well, that's what the integral of e to the x is e to the x minus 4. Add 1 to the power, and those cancel out. And that's my answer. Or you could go straight at it. You could say, you know what? You could say this is six e to the x minus 4, add 1 to the power, divide by that. And that is 6 e to the x minus x to the 4 plus c. Done deal. There it is. If I'm glancing at this problem, well, the negative 3 is a constant, and again, I'm going to do this 2 ways. One way, I'm going to use a u sub. I'm going to say, look, let u equal negative 3x. du is negative 3 dx. So, I notice then there was no point in moving that out. This is my u. Wrong coloring. And negative 3 dx is du. And wouldn't that be e to the u plus c, and u was negative 3x plus c. Or, if this is linear, I'm going to use this trick. I'm going to say, guess what? This is negative 3, you ignore. E to the negative 3x, and if I take a derivative, I multiply by a negative 3. Since I'm taking an antiderivative, I divide by that constant, which is the k in this case. The negative 3's cancel out, and I'm left with e to the negative 3x plus c. So you should start doing the problems in that sense. Number 8 does require a u sub. There's no way around it. So if I let u equal the power, remember, 5x squared. Du is 10x dx. So I'm glancing at this and notice there's no 10. Few things. First, I'll take the 3 out. And I'll write this as e to the 5x squared times x dx. I notice that's right there. I need an x dx. There's a 10 standing in the way. I could divide both sides by 10 and say x dx is du with a 1/10 as a constant. That's 3 over 10 e to the u. And that is 3 over 10 e. And what was u? U was 5x squared plus c. And there it is. Not much really, nothing new in this section. Just the derivative of an exponential is the exponential. And here, I was going to derive this for you, but we just want the outcome in this class, so that's pretty good. If you take the integral of 1 over x, remember the derivative of natural log of x is 1 over x. We've been using that for a while. If you want to go back, the integral of 1 over x turns out to be natural log of absolute value of x. And the reason for that, if I take a derivative of natural log of absolute value of x, that would be, you know what, I don't need this. Yeah, that's fine. That's going to be natural log of x if x is bigger than 0, and natural log of absolute value of x if x is less than 0, right? And that would be a derivative of this is 1 over x. A derivative, oops, I messed up. If x is less than 0, that's negative x. A derivative of this is 1 over negative x times a negative 1, which becomes a positive. And do you see you get 1 over x either way? So if you want to go back, what did you take a derivative of to get 1 over x? Natural log of absolute value of x. And keep in mind, the power rule doesn't work on this. We said the integral of x to the n dx is x to the n plus 1. Okay, I'm not liking this. I'm going to shrink this a bit more and fit all of that in. Here we go. Keep in mind the integral of x to the n dx is x to the n plus 1 over n plus 1 plus c, provided n does not equal negative 1. N equal negative 1 is actually this. The integral, the integral of 1 over x dx, if you pay attention, that is x to the negative 1 dx. If you add 1 to the power, you'll get x to the 0 over 0. That's an indication that this is a natural log. That power rule doesn't work. So if I look at number 14, well, isn't that 6 over x dx, because 5 of those cancel with 5 of those? That's 6. What's the integral of 1 over x? Natural log of absolute value of x plus c. Done. That's simple. How about here? Well, the denominator doesn't look like an x. Well, a u sub. What should you let u equal? The denominator of the fraction, if you remember, du will be 6 dx. So this is the integral. This is my u. I need a dx. There's a 6 standing in the way. I know how to fix that. And there's my du. And isn't this 1 over 6 natural log of absolute value of u? And what's u? There it is. And how about number 22? Again, I can't simplify that. I would use the u sub. The good news, you only know of one technique of integration, and that's all you're going to use. What's du? Negative 3x squared dx. So this is the integral. This is my u. And I need an x squared dx. There's a negative 3 standing in the way. I'm really comfortable with that by now. I hope we are. There's du. That is negative 1/3. Isn't that natural log of absolute value of u plus c? And what was u again? U was 2 minus x cubed. And if I glance at those again, like I said, the good story for you guys, the good news, there's only one technique of integration you have to worry about. You glance at this and you're like, wait a minute, I can't simplify that any further. Well, let me try my u sub. What do you let u equal? The denominator of a fraction. And what's the derivative of that? 3x squared plus 6x plus 9 dx. This is my u. So either I should be able to simplify that with ease, or this should be a multiple of du. Well, do you notice they all have a 3? Can't you say du is, take a 3 out, wouldn't that be x squared plus 2x plus 3 dx? And do you see where I'm off by a 3? That's a small price to pay. That is 1/3 du. All of that mess is right there. And isn't this 1/3 natural log of absolute value of u plus c? And I know what u is. Isn't u x cubed plus 3x squared plus 9x plus 1? And how about this problem? If I let u equal the denominator of the fraction, what's du? Isn't that e to the x dx? So this is my u. And e to the x dx is right there, du. And isn't that natural log of absolute value? Now, since this is always positive, it doesn't need an absolute value. You could put an absolute value, I don't mind. The book wouldn't. Not a big deal if you do. I know most students dislike absolute value, and I don't blame them. Alright. And how do these problems fan out compared to the rest? Well, here I couldn't really split them up because the denominator was more than one term. But if I look at this problem, I notice that, wait a minute, this is a single term, which means I could use some algebraic manipulation, and that saves you a lot of pain. Now just be careful, work slowly at this. And by now it's no big surprise. Add 1 to the power, divide by that. What do you take a derivative of to get 6? 6x. And 5, what's the integral? Or what do you take a derivative of to get 1 over x? Natural log of absolute value of x. So my answer is x squared minus 6x minus 5 natural log of absolute value of x plus c. And identically with this, if you try a u sub, you'll get in trouble. You'll notice you'll get something sometimes a bit messier. If you could simplify algebraically, you should. And if the denominator is a single term, then this is the way to go. This is the integral of e. 5x minus 3x is 2x. Those cancel out. And this is e to the negative 2x. And we said if you have a linear, which means the power on the variable is 1, when you take a derivative, you multiply by that. When you take an antiderivative, you divide by that. and you divide by the constant. Otherwise, you have to make two separate u substitutions. You could leave the answer like that. That's acceptable by me. Or you could say it is e to the 2x over 2 minus 3x minus 1 over 2, and you move this back down. Either way, it makes no difference. And the homework is listed right there.